Hello everyone and welcome back to homework 4.2, page 18 in most of y'all's packet, and 6th period maybe page 9, except also you don't have the retrieval, so we're actually not even on page 9 yet for you, but we'll be there in a second. Let's do some review. Match the diagrams with the angle type. Well, assuming these are parallel, they forgot to label it. Sloppy bookmakers. Then these are corresponding angles. Vertical. They're across from each other. That's not good. Ooh. Opposite of the transversal. Again, these are parallel. Or at least they should be. What else do I want to say about this? Oh, yeah. And then an outside. So alternate exterior. 6. Cool. A little bit of transformations. We know this happened in two translations, because if it was going to rotate 90, it would end up here. And there's no point that will reach you out here after a 90-degree rotation. So it's going to have to be two things. Oh, and plot twist, it's actually going this way. So, classic, translate figure until B is on B prime, or coincides, is the mathier way to say it. Coincides with B prime. Rotate until, let's go with segment BH is coincident with segment, oops, I don't have to write the word because we have a symbol for segment, B prime H prime. So you can kind of see it. We're going to slide this over there, and then we're going to turn, so it'll look like something like this, approximately. Then we'll rotate it this way until the H gets, okay. We can do this in one though, I think. Oh yeah, because we can, at first you can be like, well, you could rotate around here, but then look, J swings down onto N, and N swings over to J. And again, we're actually going the other direction, so I should say J swings onto N prime, and N swings onto N, J prime. But look how nice all of these dudes are the same distance from their prime, from their transformed image. So what sort of transformation moves things equidistant from a center line? Reflections. And reflect over, there's no grid here of numbers. Normally, if this was an XY, we would call this line y equals negative x. It's like the line y equals, slope is -1 over 1, and the y-intercept is 0, except -1 is just -1, which is this negative sign, and 0 is just nothing. So we write this as a special line, y equals negative x. And it's kind of cool, like if x is 3, y is -3. So this is 3 comma -3. So every point on this line is the same number, but the y number is the opposite of whatever the x number is. So like here, if x is 1, 2, 3, -4, this is -4 comma 4, +4, because they're opposites. Okay. But since there was no grid, you could just say reflect over the given line. How about that? Okay, 6th period, here you come. Now you're on page 9. Let the homework begin. You know those. Easy. Create an image by applying a dilation with point C as the center of dilation, a scale factor of dos. Dos is Spanish for 2. 45 millimeters. So 8, 9, 90 millimeters. Yes, it goes up here. Okay. And then 41, go to 82. Okay, I'm gonna let you finish it. Don't forget to connect all of these. And also, if you want to be really cool, you can also like put dotted dilation lines from the center of dilation, or solid, or whatever you want to do. Create an image by applying a dilation with the point C at the center of dilation and a scale factor of half. I don't know why when I'm shrinking, I always put the 0 at the figure. I mean, maybe I should put 0 at the center of dilation for consistency. I guess it's because you don't need to go past when the scale factor is bigger than 1, you have to go past the point. But if it's smaller than 1, you don't have to. So you can actually start at that end. What is going on? 51? I can't cut 51 in half. Let's say it's 52. I mean, you can cut 51 in half, obviously, but. And once you do that to all 3 points in the triangle, you should have a cool triangle that is half the size. And there's my line of my dilation connector. Should have 3 of those, and then a half-size triangle right about here. Right about yay. All right. Loads of fun, loads of fun, loads of fun. Okay. This is fun. I'm just going to do one of these for you. What is that? 18? 17 and a half? Come on, Smalls. 16, 17, 18. 18 times 3. I'm not a math teacher, but I believe that is 54. Which would take us up to this point way up here. Right. Yep. It blows out 3 times bigger. It's pretty cool. It's a pretty cool one. This one is a quarter. So all these distances, you cut them down into quarters and just go a quarter of the way. So about like that. I mean, actually measure it, right? Ooh. Decide if the 2 given figures are similar. Include as many details as possible about the transformations used to justify the similarity. For example, if a dilation is used, state details such as the center of the dilation and the scale factor. How would you determine the scale factor? Okay, so this is, we're going to have to pay attention to the primes here, since this is where you end up. And this is the pre. I'm not on the screen at all. Let's try that again. That's where you end up. $13. This better be 26. Yes, let's call that 26. So it's half, because we ended up always take where you end up, divide by where you came from. Scale factor is a half. Find that center of dilation. You got this. Yeah, okay, I think you get it. All right. Is there anything left? Ooh. This one has a cool center of dilation. It's on one corner of the triangles. And the go. Based on the given image and pre-image, determine the transformation that occurred. Cool. Justify the transformation occurred by showing the evidence. So, for example, the transformation is reflection. Show the line of reflection. Prove it is perpendicular bisector of all segments that connect corresponding points from the image and the pre-image. So connect corresponding points from the image and pre-image, and this should be on a segment that is a perpendicular bisector to the line of reflection. This is review. That looks like a mouse to me. Why does that look like a mouse? Ooh, this one could use. This one uses our new transformation. So now we have 4 transformations. All right, have fun with that homework. Look at this, only 11 minutes long. That's great. I wonder, do you guys pause the video and work on each problem as we go, or do you watch the whole thing and then go back? Cool.